Hello everyone, my name is Ajay. So in this video I'm going to explain you about stack data structure. So I'll be showing how you can implement the stack data structure by using linked list. So for suppose I'm having 1, 2, 3 elements. Let's see how we can actually insert it into this stack. So first I'll be having 1, and next I'll be having 2, and next I'll be having 3. Okay. So these are 3 different nodes. For 3 the next node is 2, and for 2 the next node is 1. So this is the stack. So if you can see, I'm having 3 at the top of this stack. So basically in a stack you actually follow an approach called LIFO, LIFO, which is known as last in first out. So stack is a collection of items. So in stack, if you want to remove any item, you will remove the item which is inserted last. So in this scenario we inserted 3 last, so it is, so if you want to remove an element, then we have to remove element 3, so which is at top, which we inserted last. So that is our stack. So let's see how we can implement stack data structure. So I've written the function, basic functions here. Push, pop is empty and p. Push is for inserting item into the stack. Pop is for removing the item from stack. Is empty is to check whether the stack is empty or not. Peek is to return the element which is at top of the stack. And also I'm using a pointer called as top, which will be representing the element which is added, which will be representing the item which is added last of the stack. So let's implement push operation for the first time. So I'm also having class node here. So for each node we'll be having the next pointer and also data. Also I actually written the constructor for making it simple while creating a new node. So let me implement the class stack. So I'm having class stack. So let me implement push operation first. So public void push. So for inserting an item we need data. So I'm passing data. Okay. So first I'll create a new node equal to new node by passing this data. So that way I will have the new node ready in n. So for the first time, if I'm adding element into this stack, then the top pointer. So let me also declare pointer top, which will be node top. Okay. So I'm having the pointer top. So I created a new node n by passing the data in the push operation. So for the first time the top pointer will be null. So when the stack is empty, the top pointer will be null. So in that scenario I'll just assign the new node to the top. So if top equal to null, then I'll just make top equal to new node. Okay. Else so if I'm already having few items in the stack like this, and if I want to add a new item, let's see how I can do. So for suppose if I want to add another element 4, so if you want to add any element in the stack, you have to add top of it. So for adding the element top of it, so I'll create a new node 4, and I'll just make new node dot next to top. So if I make new node dot next to top, then I can join this element to the stack. So for that I'll just make n is the new node here, so new node dot next will be top. So by that way we can join the new node to the top new node to the stack, and once you join the new node to the stack, then you have to move the top pointer to the top of the stack. So currently the top pointer is here, so I have to move the top pointer to here. So for moving the top pointer to the top of the stack, when we add a new item, we have to just make top is equal to, so I'm just assigning the new node to top node. So whenever I add a new item, I'm just moving the top pointer to the new node. So for that I'm writing this line. So that's for adding a new element, that's for pushing an element into the stack. So this is the implementation. So now let me implement the function pop. Pop is nothing but removing the element which is top of the stack. So that is nothing but the element which is inserted last. So let's see how we can implement that. Pop. So pop will actually return the data as well. So pop function will actually delete the top element and also return the data in the top element. So for that reason I kept the return type as int. So let's see how we can remove the top element. So here if you can see, so here if you can see, for removing a top element, you can simply make the top element to its next element. So if I assign the top to its next, then I will just eliminate that top element. That way I can remove element which is at top. So let me implement that one. So I will actually use int data and I'll assign it to 0 first. So I'm using this variable to store the value of the top variable, top node, to store the value of top node. So I'll check if top is not equal to null. So I'm making sure top is, I'm making sure the stack is not empty. So if the stack is not empty, I can remove the element which is at top. So at that time, so I will just store the data of I will store the top data. So I will be storing the top data in the data variable, and I will just make the top, I will assign the top pointer to top dot next. So that way the top pointer from here comes here by eliminating this element. Okay. So that is about this condition, and finally I'll return the data. Okay. So this is the implementation for pop function. So I'm just checking if the stack is not empty, then I'm just moving the top pointer to its next pointer. That way I can eliminate the top node. That's about the pop function. So let's see how we can implement isEmpty. So isEmpty is to check whether the stack is empty or not. So for that, the return type would be bool. So I'll just check if top equal to null. That means there are no elements in the stack, so there I will return true. Else return false. So I'm just checking whether if top is null, that means we don't have any elements in the stack, so I'm returning true. Else I'm returning false. So that is the empty function implementation. Let's see how we can implement peek. Public. So peek is the function where we will actually return the element which is at top. So for that the return type would be int, and I will name it as peek. Okay. just return element which is at top, that is top dot data. Okay, so that is the implementation of peak function. So all these four functions will be taking the time of big O of n, which is constant time. So that is our time. And also, if the code is not clear, and anyway I'll be posting the code in the link of this in the description of this video. So if you want to get the complete code of implementation of the stack using linked list, you can just go to the description of this video. You can find the link over there. So if you have any questions, you can post them in the comment section of this video. Thank you for watching my video. Thank you.